electric field. Electric field is region inside of which one charges and
Not one
influence.
charge. Full charges.
Uh,
Full charges. Бүкіл charge'dır.
Full charges. Electric field formula equal time Q over D square. Properties electric field lines. One originates
I can see you. Roshan.
positive and terminates
Stop.
at negative charges.
Hello.
2 never cause. 3
Roshan.
electric field is always at the
Roshan,
I can see your face. Сен түріңді көрейік та? Start from дұрыстап. Көрінбей тұрғанда қайтадан. Саған көрініп тұр ма не?
Я ол компьютерде солай көрініп тұр ғой деймін.
Маған дауыс естілмейді.
Дауыс естілмейді?
Иә. Ақырын естіледі.
Онда сенің компьютерінде бір проблема бар. Маған нормально бәрі естіліп тұр. Соны сенің түріңді көрсек, и басынан бастасан, иә? Start from the beginning, please. Что-то көрмей тұрмыз. Сенің камераң қандай? Онда компьютердің камерасы ма? Или қандай?
Жоқ, телефондікі. Маған камера қоспа дейді, а то свет ұстамайды дейді.
Қалай?
Маған онда шығады всегда. Неме, камера қосаңыз, сізде свет ұстамайды дұрыс.
Ну, давай, айта бер, жарайды, окей. Міне көріп тұрмыз ғой сен енді. Давай, айта бер. Старт.
Басынан ба?
Yes.
In the last lesson,
On the last lesson.
we pass
On the last
lesson. On the last lesson, we passed electric field. Electric field is the region inside of which all charges
full charges
and full charges and influence. Electric field formula equal time Q over D square. Properties electric field lines. 1. Originates at positive and terminates at negative charges. 2. Never cross. 3. Electric field is always at the tangents to electric field lines. 4. Intensity of electric field lines more near to electric charges.
But the topic that we covered on the last lesson was related to electric potential energy. Ол potential energy еді ғой. Сен неге electric field айтың?
айтып отыр, айта алмай қалған.
Okay. What about the electric potential energy? Кім айтады?
Ағай мен айтайыншы.
Басқа біреу жазылған сияқты еді ғой жерде. Look at it.
Жазылған пойды.
Так. Review should be made by Dilnas and Ерасыл. Кім бар мұнда? Dilnas па, Ерасыл ма? Кім бар? Ешқайсысы жоқ па не? Олар қайсысы осы группада еді? Dilnas ба, Ерасыл ма?
Dilnas осы группа.
Dilnas қайда енді? Зайра апай, осы Dilnasды анықтансаңыз, неге жоқ сабақта? Okay, let's go on. Бауыржан, сен айтасың ба?
Yeah.
Okay, please.
On the last lesson, we passed the electric potential energy. Electric potential energy stands with the help of electric field. If we imagine electric field plate, Then, as we know, electric field lines originate at positive and terminate and at negative charge, and parallel lines between themselves mean that electric field is uniform or constant and observe its force. If force applied to positive charge is in the same direction with electric field, if force applied to negative is in negative charge is in on opposite with electric field. A formula of force equals F equals electric field times Q charge. If charge is balanced between this mg or p is opposite direction or perpendicular for Q charge, p or mg equals a q, then mg equals a q, then q equals mg over electric field. And electric potential energy has only magnitude or just electric potential energy have scalar volume. Formula is electric potential energy is kq1 k times q1 times q2 over the for like charge the farther away the favor, for unlike charge as they come they decrease and approach zero. Value of electric potential energy is joule. One key moment when you calculate electric potential energy, you have to keep in mind the change of charge.
The sign of a charge.
Work also will done if work that formula is W equals delta electric potential equals electric potential 2 minus electric potential 1. If equals minus, then the system does the work itself. If the opposite or if equals plus, then we not system the work when the distance change.
Okay, is it all?
Hold on.
Thanks. Thank you. That was pretty good. Okay. The next lesson. Now the next lesson subject is electric potential, but before this, we still deal with the stationary charges. And if I want to find any work done here to move, for example, the charge of Q2 to a place given, to a position of P, there are two ways indeed. The first one, as we mentioned before, is the way of electric potential energy. So in order to find the work, I have to find the change in potential energy. So what I do, first of all, I will find out the potential energy. Let me write here K, Q1, Q2. And over distance, instead of distance, let me write it 15 times 10 to the power of minus 2. And that will be squared. First distance, I mean. This first distance. And of course, sorry, it should be the final, it should be the final point indeed. So let me write here D1 and D2. So that will be more clear, I think. So I'll write here that the distance of 10 centimeters here is my D2, and distance of D1 here is my 15 centimeters. So in order to find the change in potential energy, since I moved this charge from given point to point P, my final position, of course, will be point P. So that is a distance of d2. So I'll write here d2 square. And minus of k times q1 and q2 over d1 squared. So that will be the change in energy. That's the way that we've covered it on the last lesson. And we said since this charge one is positive and the second one is negative, I mean they are unlike. Of course, the energy will be negative here, and here that will be negative. And it's not surprised that the change in energy, of course, I mean the work done will be here negative, by the way. It means that if you release this charge will go on by itself to the position of P. That's the first way. Let me write here, that's the way of electric potential energy. Electric potential energy. So the formula for potential energy, electric potential energy, as you remember, that is K times Q1, Q2 over D. So the D here is the general. Now, the electric potential is the energy, electric potential, indeed the energy per unit of charge. What kind of charge? The charge that I move here. So I mean, I have to divide the potential energy by Q2. So I'll have here, that is K times Q1 over D, because I simplified the Q2 here. You see? Now, I mean, the formula for potential energy will be K times Q1, Q2 over D. But if I divide it by Q2, it means that I will simplify one of the charges here. I mean the Q2. So I left only here K times Q1, QD. So the formula for potential, electric potential, is K times Q. Let me write Q, not Q1. Since I write the general formula. The charge that it's not moving charge. Keep in mind that the charge that I move here is indeed Q2. So in order to calculate the potential, I have to calculate the potential made by the charge that's stationary. So K times D, K times Q over D. That's called as electric potential. The unit for electric potential energy, as you see from the formula, that is the energy is measured in joules, and it can be divided by columns here. Indeed, that can be the unit for electric potential, but we have a special unit that's called as volts. And it's named in honor of Alexander Volta, who discovered that. And now the second way to find the work done in order to move the charge from a given point to that point, to point P, is the way of electric potential. What can I do? The first one, by the way, I can find the potential at point that is D1, sorry. So my potential at point D1 made by the charge of Q1, K times Q1 over D1, that will be my initial potential. Let me write it here as V1. So the final potential, since I moved this charge here, the potential made by the first charge on the point P is K times Q1 over D2. And then what I do, I will find the change in potential, that's V2 minus V1.
V1.
As you see here, that is K times Q1 over D2 minus K times Q1 over D1. I will find the change in potential, and then in order to find the work done, I have to multiply the change in potential by the charge that I move. But the charge that I move is the Q2. So that's why if I multiply it, if I open the brakes here, KQ1 over D2 minus K times Q1 over D1 and times Q2. So if I open the brakes, indeed, that will be the same as change in potential energy. By the way, electric potential is also, it doesn't have any dimension and direction here. So that's why that's the scalar quantity. Let me write here electric potential. electric potential, and that is scalar. So it's easy to find potential at any point because you don't have to you don't have to draw the directions here for any potential.
Тек қана модуль ғана бар.
Yes. But we have to keep in mind again, the sign of the charge that's given. For example, if I want to find the potential made by Q1, there is no problem because I have the positive sign here. So that's why the potential will be also positive. So if I want to find the work done, I have to calculate the potential. Let's do it together. So that's 9 10 to the power of 9 at the distance of d1, at initial distance, I mean, times q1, that's my charge here is 5 10 to the power of minus 6 because it's microcoulombs, and I have to divide it by d1, that is 15 centimeters. So let me write here 15 10 to the power of minus 2. I convert it to meters and I simplify. I get the 3 here and simplify this one. This goes up with the positive sign, you see. So I'll have here in the 3 times 10 to the power of, since I have here 11, 10 to the power of 5 volts here. So I have 11 minus 6, that will be 5. And let's calculate the V2. By the same logic, I'll have 9 10 to the power of 9 times again 5 microcoulombs. I still use the same charge here because the only charge that's stationary is this one. So, but I moved the Q2. So I don't use now, in order to calculate the V2, I don't need any Q2 here. And here I don't need the Q2 also because the Q2 is not stationary, it's moving. So that's why I'll divide here by 10 10 to the power of minus 2 here. Again, the same logic. I have 2 here, and then I have 4.5 times 10 to the power of 5 volts here. So the difference now between these 2 points here, since 4.5 10 to the power of 5 minus 3 times 10 to the power of 5, I'll have 1.5 times 10 to the power of 5 volts. Now, in order to find the work done, by the way, work done, I have to multiply the change in potential here by the charge that I have, that I'm moving here. So again, I remind you that I move on the Q2 from the initial position that was 15 centimeters apart to a point P that's 10 centimeters apart. So that's why now 1.5 times 10 to the power of 5, I should multiply by 2, sorry, but minus 2, 10 to the power of minus 6 here, microcoulombs I have still here. And these powers are simplified. I'll have here 3 times 10 to the power of minus 1. Indeed, I have here minus here sign because I multiplied by minus. I have 2 here. And that's unit is joules. So I mean it's minus 0.3 joules. So the minus sign here, again, as Baujan said, since I have the negative sign here, it means that the work done by a system, not by me. It means that if I release this charge from a point 15 centimeters apart, away from the point from the charge Q1, it will move to point P by itself. I don't need to force it. Yes. So negative sign means that. Do you understand here?
Yes.
Again, first of all, what I do, I calculate the potential made by the first charge on point 15 centimeters apart, as is here. And then I calculate the potential at point P made again by the stationary charge, that is Q1. And then I found out the change in potential. So I have to substitute the V2 minus V1. Okay. So I'll have here 1.5, the number that I have here. And then I have to multiply the change in potential by the charge that I move here. So I moved the charge of minus 2 microcoulombs. So my answer appears to be negative. That means that the system has done its work here. It means that if I release it, it will move up to this point from a given point to a point P by itself. Okay. May I continue? Shall I start? Okay.
Yeah.
Next one. Okay. Sorry. Huh. And now, as we said before, the electric field is given. By the way, the electric field is uniform. Why it's uniform? Because we have the parallel lines here. That means the electric field is constant here. So relative to the previous example, which potential is greater? Is it at point B or at point that is 15 centimeters apart? Let me write here that I have here the point A here. At what point I have the greater potential? Which point has got the greater potential? Is it point P or point A? What do you think? So let's look at the calculations. That's the potential at point A, and that's potential at point P. Of course, the potential at point P is greater.
Yeah, I can
turn. Since I have the positive sign here, it means that V2 here indeed is greater than V1. I mean, the potential at point P is greater than potential at point A. So it means that since as I go closer to point, to a positive charge, of course, the potential will increase. For example, at this point here, if I have any point here, let me denote it as point B. Of course, the electric potential at point B will be greater than P, the potential at point P, and of course greater than the potential at point A. Do you understand? It means that as I go closer to a positive charge here, the potential increases. And the next question is related to this. Not question. The theory that I mentioned here. If I choose any points here, let me write here that is point, let it be P1, and here somewhere here it's point 2, and somewhere here I have the point 3, and here I have the point 4. My question is, which potential is greater?
Which potential?
Yes, is the where I have the largest potential, at first point, second, third maybe, or at fourth point, sorry. At which point I have the largest potential? What you think?
Так, да, кажется. Алай бірдей болмай ма?
No. So you have to just look at the logic that we have here.
Which part?
As I get closer to a positive sign, the potential increases. Do you understand? So as I get further away, of course, the potential decreases here from a positive charge. Again, I remind you. So at which point the potential is largest? What do you think?
Third part?
Huh?
Third part?
Third? No. So what we said about the electric field lines, we said that they are starting at positive and terminating at the negative. So I will assume that I have the positive side here and negative here. Okay, I assume that the positive side is here and negative is here. So it means that the positive, I will assume that the positive charges are located on this side here. Okay, and what I said in the previous example, I said that as I get closer to a positive charge, of course, the potential will increase. Do you understand?
Сонда бір болады.
Yes, so the potential at first point, sorry, at point 1 is greater than potential at point 2, and it's greater than potential at point 3, and it's the fourth position here is the smallest.
Плюсқа жақын тұра ма?
Yes. So the points here that are close to a positive again, positive side, are greater always. Okay. Assume that I have here a mountain here. Okay. And I have the mountain here, and I'm asking you which height, which altitude is greater. Қайсының биіктігі биік деп сұрап тұрмын да. Қай нүкте биік тұр деп сұрасам, сендер ойланбастан не дейсіңдер? Бір дейсіңдер. First, of course, because it's closer to this side here, to the top. Дәл сол сияқты мынада да potential, let's assume that the potential is something like the altitude. Биіктік сияқты деп есептендір. Okay. So, of course, at the edge of this here, at the lowest point, of course, the potential is smallest, and here it becomes greater, and here it's greater again, and that's greatest at the top because we have it. So,
yeah.
And a positive charge, if I have a positive charge here, okay, you can assume it as a stone. Do you know what a stone? Тас сияқты, иә? Тас сияқты не істейді? Тас қалай қарай домалайды? Астыға қарай, да? То есть астыға қарай дегенде to a point where I have the less potential. Потенциал, яғни аз болған жаққа қарай домалайды, дұрыс қой? So that's why the force applied to a positive charge in an electric field is in the direction of electric field. Соның бағытымен бірдей. Неге? Өйткені үлкен потенциалдан кішкентай потенциалға қарай өте береді. What about the negative charge? Negative charge is like a balloon. Okay? And the balloon, you remember, it's rise up here. Okay? Ол үстіге қарай көтереді. Демек, яғни from less potential to high potential it goes. Түсінікті ғой, иә? Неге? Өйткені мына жағы біз плюс деп ойлайтын болсақ, өзі солай қарай тартылады. Okay, again, I made a similarity that the potential is related to something like altitude, height here, and the electric field here is something like a mountain, and the positive charge is like a stone, and negative charge is like a balloon. Okay? Okay, now the question is, in order to move any positive charge, suppose that I have a positive charge here, where I can make from which points, if I move from which point to which point, I mean from first to third, maybe from any 2 points, where I have the maximum work here done, where I can do the maximum work. If I move from which point to which one, between which points I have a maximum work. What do you think? If I have the positive charge here. By the way, the work should be done by me.
Қандай максималды жұмыс жасалады,
Яғни қай нүктеден басқа қай нүктеге жылжытқанымда мен өзім максималды жұмыс атқарамын мына жерде. Қалай ойлайсыңдар? Қай екі нүкте арасында жылжытқанымда оң зарядты.
1 мен 4 емес. 1 мен 4 емес па?
1 мен 4-дің арасында бірақ қай нүктеден бастауым керек?
4-тен басталу керек.
Конечно, of course. So I have, again, in order to find the work done, what I should do, in order to be maximum, okay, delta V should be maximum. Now maximum болу керек. And I have to multiply it by Q2, by Q. V maximum болу үшін, delta V maximum болу үшін, не болу керек? I have to subtract V maximum minus V minimum, okay? What's the point where I have the maximum potential? Қай жерде ең үлкен потенциал бар? V1 minus
V1
V4.
minus
Бірақ
V.
мынау менде initial бастайтын нүктем, иә? А мынау менде
Final.
final, yes. Do you understand?
Yes.
Yes.
Ал минус заряд үшін қандай болады? Ол наоборот. Минус зарядты Vmax-ты табу үшін, да? Work maximum табу үшін не істеуім керек? Мен онда наоборот
Minimum.
4-тен
Initial that.
Third
Initial then
болады,
final.
да? Ал final менде
Final V1.
Ага. Түсінікті ма? То есть менде
Yeah.
initial V1 болады, наоборот, final O болады. Түсінікті, да?
Yeah.
Okay. Thank you. By the way, негізі, енді мына нүктелерді қараңдар. Мына нүктедегі мен, мысалы, let me write here V2, and here I have the point V5, sorry. Something like this. Мынандай бір нүкте болса. Мына екеуінің потенциалдар туралы не айта аласыңдар?
Бірдей болады ма?
Бірдей болады. Неге дейсіңдер? Өйткені дәл
Бірдей.
биіктік сияқты, да?
Yeah.
It's something like altitude, яғни биіктік сияқты. Мына жерде қай жерінде height бүйік десем, V5 о V2 десем, қайсыны айтасыңдар? 5-ші нүктеде ме или мынада ма десем, қайсыны биік деп айтасыңдар? Қай нүкте биік? Екеуі тең.
Екеуі.
Okay, so this lines here shows us that the potential along these lines are the same. То есть мына линияда бәр жерде потенциал бірдей, мына жерде бірдей, мына жерде бірдей, и мына жерде қайтадан бірдей. So мына lines'тарды по идее бүйтіп айтады. Equi potential lines. Мына жерде потенциалдар бірдей. То есть, қараңдар, жұмыс атқару үшін не болу керек? Бірінші, change potential болу керек. Содан кейін жылжып атқан бір Q болу керек. Егер мен 5-ші нүктеден 2-ші нүктеге бір зарядты жылжытсам, if I move any charge from point 5 to 2, what will be the work done here? Мына жерде жұмыс қандай болады?
0.
5-ші нүктеден,
0.
0. Кім айтты?
Мен. Ой, Аяжан.
Аяжан, әрине. Өйткені мына екеуінің арасындағы potential difference неге тең?
0-ге тең.
0-ге тең, өйткені екеуі бірдей. Do you understand?
Екеуі бірдей.
Yes.
Түсінікті ғой,
Yeah.
Екеуінің арасында потенциалдар бірдей болған үшін менде не істейді? Ол жерде ешқандай жұмыс атқарылмайды. Now equipotential lines деп аталады. I hope that's clear. Түсінікті, иә?
Түсінікті.
Мынаны жазып алдыңдар ғой? Ну ладно, кейін де жазып аласыңдар. Мынаны жіберем. Now, the task is easy. We have to find the potential at point P. Let me write here V. Find the V total at point P деп жазып қояйын. Now let me give you 2 minutes to solve this problem because it's so simple.
Сонда бұны табу керек пе?
Yes, we have to find the potential, total potential at point P. Both of the charges are positive. Екеуі де бірдей, иә? То есть, яғни екеуі де оң заряд. By the way, we have two potentials here. Potentials. The first potential is made by Q1 and the second by Q2. And they're both of them are scalar quantities. So I think there won't be any problem.
он бір бүтін он алты көбейтілген онның алты дәрежесі бола ма?
11,16 dedin mi?
11/100-ден 16 көбейтілген онның алты дәрежесі.
Немесе
Жібер көрейік.
1/116 көбейтілген 5 дәрежесі десек.
Көрейік ал. Жіберіңдер көрейін.
Мен қазір почти.
Окей. Okay. Okay, first of all, the potential made by first charge at point P. So I'll have here, that is K, let me write the numbers immediately, 9 10 to the power of 9 times 0.6 times 10 to the power of minus 6 and divided by the distance, that is 4 times 10 to the power of minus 2. Okay, now I'll have here indeed 0.15, but let me write here 1.5 and I will write here that the power is minus 7. So 1.5, I have here 9 and 4, 13.5 times, this goes up with a positive sign here, 11. So I'll have here 10 to the power of 4 volts. 13.5, 10 to the power of 4 volts here. That's potential made by the positive charge 1 at point P. So the distance that I have to calculate is the 4 centimeters. I have to use the 4 centimeters here, and it's not square, by the way. So the V2 made by the second charge at point P is, again, I put the numbers, 9 10 to the power of 9 times, that is 2.5 times 10 to the power of minus 6 and over 3 times 10 to the power of minus 2. I will simplify these numbers here by 3, and then I have 7.5, sorry, 7.5 times, and again I have 11 here, it's 10 to the power of 5 here. So that will be, if I just take it to the same power, I'll have here 1.35 times 10 to the power of 5 volts. So the total potential energy at point P, at point P, is the sum of these two. Potential made by the first and the potential made by the second charge at point P. So I'll have here 1.35 plus 7.5 and the same power. I will take out the brakes here, 10 to the power of 5. And I have here 8.85 times 10 to the power of 5 volts. That's the total potential.
5 сантиметр дегенде немеге алмаймыз, ja?
No, we don't use it.
3/4 ғана аламыз ба сонда?
Of course. So
Yeah,
you
you
have to
can pin
understand that the distance from the first charge to point P is 4. So that's why we use 4, not 5. And the distance from the charge 2 to the point P is 3. So that's why we use 3 centimeters here, but not 5 exactly. Okay?
Mhm.
Ja, оны айтам.
Okay. Second, suppose that I have here 2 points here that let it be V1 here, that's 700 volts, and V2 500 volts here. So I moved the positive charge from the point of 700 volts to 50 volts, and my charge here, let's assume that since it's positive, that's 5 microcoulombs here. So what's the work done in order to move it from point of 700 volts to 50 volts. Please try to find it your own. Again, 2 minutes are given for this question. It's again easy. Five microcoulombs. 5 microcoulombs charge is moved from a point of 700 volts to a point with potential of 50 volts. What's the work done?
Ағай 3,25 көбейткен 10-ның -3 дәрежесі джоуль болады.
Do you have the work done? Is it positive or negative, first of all?
Сонда 0 бүтін 0,325.
No, is it positive or negative?
Minus negative болады.
Negative?
Я негатив болады.
Okay, let's look at it now. Of course, first of all, in order to find the work done, what should I do? I should find the change in potential, and then I have to multiply by charge given. Change in potential, of course, that is V2 minus V1. I moved the charge here from the greater potential to a lower one. So that's why 50 minus 700, I'll have minus 650 volts. So that's the potential. Okay. Now the work done, of course, is minus 650 volts. I have to multiply the charge by the charge. That is 5 10 to the power of minus 6 microcoulombs here. And here I have minus 3,250 times 10 to the power of minus 6. Is it correct?
Yeah,
so minus 3.25 times 10 to the power of minus 3 joules here. So the work is negative. I'll look at...
Ағай, можно я оны, типа, қысқартуға еще?
Ля, болады. 1000-ға бөлу сразу.
Мына жерде біреу жіберген, кім жіберді? Аяжан ба? Аяжан, was it correct? Бірдей болды ғой, иә? Okay, but in scientific notation, яғни сен мына жерде minus 0.00325 деп жазасың, бірақ scientific notationда былай жазу керек, та? Ғылыми түрде осылай жазады. То есть, the number that you have here should be between 1 and 10. 1 мен 10 арасында болу керек, okay? But it's correct. Now, indeed, if I move the charge былай жүргізсем, мына нүктеге, сондай жұмыс атқарған боламын. Егер мен мынандай траекториямен жүргізсем, дәл сол нүктеге, или вообще басқа бір нүктеге болады. Онда жұмыс қандай болады? Разница жоқ, дәл сондай болады. Түсінікті, да? То есть, яғни, the work done by electrostatic forces, work done by electric forces doesn't depend on path. Yani kay jolmen жүргөнүнө байланысты эмес вообще. Анатында. That's important thing. Сол үшін мына electrostatic force'тарды conservative force деп атады. Conservative. Yani атқарған жұмыстары мына неге траекторияға байланысты емес. Doesn't depend on a path or trajectory. The same things. Trajectory.
Оқту.
Huh? So I made mistake here.
Оқту.
Trajectory. Wait again. Trajectory. Okay. Now it's the
Ха.
Okay. If it's okay, I will send you тағы да бір мына жерде презентацияны жіберем. Сол презентацияда тағы да бір есеп бар. I have one more question. Негізі екеу бар екен. Ну ладно, екеуін де шығаруға болады. Соларды шығарып жіберсеңдер болады, яғни шығара аламын деген адамдар. Қанша болды уақыт? Уақытымыз нормально болды ма? Let me look at it. Okay, let's call it today. Thank you very much. Рахмет бәріне.